Hello, everyone. I'm coming on live for day 5. Yes, this is Friday. It's day 5. So this is day 5 of our Build a Safe Home live series. So I've been coming on every day this week. And so there's 5 videos that I've done that are live and being recorded. So you'll be able to watch the recorded version as well. And today we're going to talk about walls and openings. So let's get started on that. I'm going to open some of my windows here in case there's any notes I need to check on. Let's see. Sorry. Sorry. So today in your email, you should have gotten the bonus checklist, what to ask your builder checklist. And so check your email for that. You should have been watching the Build a Safe Home intro course. It is long, so if you've had to take a couple days, that's okay. But you can watch it as many times as you want this week only. So it's a limited offer. It is our way of giving back for the holidays. So I hope this is something people are able to take advantage of. And so we're going to talk about this final module in the Build a Safe Home course. It's actually, there is a bonus module. But we're going to talk about walls and openings. So just to summarize what we've already talked about, we've talked about site and climate. We talked about building design. We talked about foundations. Then we talked about roofs. And now we're talking about walls and openings. And so these are the basic building block beginning to what you need to know to build a safe home. Obviously, building design is the piece that's encompassing everything. They're all critical. So I do sell the individual modules of the master course separately. However, I would really recommend that you get the whole thing because they do build on each other, and just like our bodies are a system when we're trying to recover our health, our buildings are a system too. And everything is interconnected. And the same thing is true of materials. People are often asking me, especially with walls. We're talking about walls. And so what materials should I use for my walls? What kind of insulation should I put in my walls? Does my wall be breathable? Is it not breathable? So any material can be, well, almost any material can be done well. Some materials are harder to do well. But it's going to depend on your climate. Your site is going to have to be managed properly because we have this thing called rising damp that can draw water up into our walls against gravity by capillary action. So there's nothing we can leave out. And then the roof, if we can do roof overhangs, then we can protect our walls, even though we're still going to try to do the best possible solutions for our walls. So in terms of walls, the first part is the walls generally and openings. We do talk about materials in this module. And like I said, in every module, there's sub-chapters. We talk about drying and draining. So our walls are going to get wet. They're all going to get wet. We need to allow them to get wet because it's going to happen. What's key is how do we let them dry? Will the water drain out that gets in? And will it dry? And then finally, are the materials that we're using going to be durable and be able to handle that? So in the lesson 4 of this section, we talk about a concept called rain screens. And that's bringing this all together. That is the premier type of wall that I would recommend. It can be done with a lot of different materials. It's actually the way masonry walls should be done. However, I can tell you, in checking around on residential projects that I just happen to be walking by or driving by, that they're not allowing a drainage plane. But what's behind the finish also has to be moisture proof. It needs to be an air barrier. So these are all the pieces that need to come together to keep our walls dry. Yes, we want our walls to breathe, quote unquote, breathe. We don't want to wrap our building in a sheet of plastic, for instance. Just imagine if you were going to go jogging and you're going to wear a giant garbage bag. It'd be pretty nasty. It's not going to breathe. However, if you put on a material that's like Gore-Tex, I think is a brand name, but it's a waterproof, breathable material, then that would be much better. You're going to pay a lot more money for the material that's going to be breathable and still waterproof than you're going to pay for something that's going to be the garbage bag. And so we have to be willing to do that because we're not going to see it. Now, there's a lot of other things that go into walls that people ask questions about and that I do talk about. They have this green board that has a coating on it. Call it a zip system. We have products like Tyvek or Typar. There's a lot of brand names that lumber yards have their own name on the house wrap system. We do want to know about the permeability of the product. So permeability is breathability. Is it able to dry? So something that's plastic, for instance, is not going to dry. That's the garbage bag analogy. But something that is a fabric that is waterproof and can dry, like a Gore-Tex, has a permeability measurement to it. So this is something that they evaluate. And so when you look at your products, somewhere in the specifications of that product, it's going to be able to tell you what the perm rating is of that material. We talk a lot more about this in the course, but it's an important concept to understand. And then so we don't want to trap water in our enclosure. Even though we've done everything possible to keep water out, inevitably there is a chance that somehow other weird way, or it could be from a rain event or something, that water could get in. And if it does get in, we want it to dry. So a lot of the solutions that are out that are new are really counting on the water wall has to be dry. And the challenge is if you are get water in the wall for some reason, because some human made a mistake or something happened in the environment. It's kind of like our bodies. We're healthy one minute and the next minute we're not. So whatever kind of an event, maybe it's an animal crawled in. I've actually seen situations where there's infestations of rodents that can lead to moisture inside of a wall. That needs to be corrected. There's even bacteria associated with that. That's pretty nasty. It's not a lot necessarily, but it is very much something that would affect health. So we want to be able to let our building dry in both directions. And there's different times of the seasons of the year, depending on what climate you're in, also varies, that sometimes our buildings will be drying to the inside and sometimes our buildings will be drying to the outside. Then you throw in the concept of the stack effect, and that is a natural tendency for air to move through a building. There's actually a number of ways infiltration of air gets into our buildings, and even the tightest building ever has probably a way that some air is getting in. One analogy that I use for people when they think that they have a really tight building is, and most of us that have a tight building, it's not really that tight. Even the code requirements for tight buildings, most of the code agencies have actually raised the number to a higher number. That means there's more infiltration possible than there probably should be, because it's almost impossible to achieve. But think about that. It's in a cold temperature or hot temperature, and you have all your windows and doors closed, and you run your exhaust fans, you run your kitchen exhaust fan, which are venting outside, you run your furnace or your air conditioning, and maybe you run your dryer vent. But everything's closed up. Have you ever heard of someone suffocating in their home because they ran out of air? I don't think so. I haven't heard of anybody. There are cases in very tight homes that there can be backdrafting of carbon monoxide from combustion appliances like a water heater or a furnace that's exhausting. That is possible to have happen. But I've never heard of a situation ever where people in the home actually ran out of air. Meaning it was like they have a plastic bag over their face and they are suffocating because there's no more oxygen in the house because they blew it all out. It doesn't happen. Nature wants an equilibrium, and nature is going to find a way to have an equilibrium. And nature is going to find the air that's the makeup air some way, somehow. And if it can't get it because there's no windows or doors open, it's going to find wall cavities. It's going to find a place out of your attic. It's going to find places in the crawl space or the basement, someplace where probably you actually don't want air to be coming into your home. So when people do testing that's called blower door testing, that's a test I would recommend to see how tight your home is. Don't do the blower door testing though just to get a number. That's not really very helpful. We want to do blower testing. I recommend doing blower testing, and this can be done to evaluate your walls, and I recommend this in new construction. And when you do your wall, you're going to do your walls, your roof, you're doing the whole assembly, but basically you're pressurizing your home in such a way that you're blowing, they put a huge fan to blow air out. And when you blow all the air out of your house, then air is going to be coming in. And so there are different ways that you can evaluate where that air is coming in, but you do want to know where it's coming in. It could be coming in around outlets. It could be coming in around light fixture openings. It could be coming in where there were gaps in insulation that even in new construction that were overlooked. So I have clients that I've reviewed that are in new construction homes and have places now that it's getting cold where they're noticing that in a bedroom that it's really cold in one place. So I have some videos that I'm going to be posting on, they're going to be on Instagram, I believe. They're coming because I've recorded them, and then I try to trickle them out, where actually what's happening in a new construction home that I've seen is they've missed. There's, again, coordination. Walls have a lot of coordination between the people who are putting in the windows, how that's being sealed. Usually a person doing the insulation is another trade. Oftentimes a person putting on the siding or the brick or whatever the finished material is again another trade. Then there's drywall, that's a different trade. We have electrical, we have plumbing, and those are coming in between our walls. So usually there's some lighting outside, there's outlets outside, and there's outlets inside. And what if those are back to back? Or what if they're not sealed properly? That can be an avenue where air can move through. When we have air moving through our walls, there's the potential for condensation, because with air moving through the wall can be vapor. So water vapor is carried on air currents. And just like that glass of ice water in the summer that's on our picnic table that's condensing on the outside and leaving a giant puddle on our table, we can have warm, moist air, which may be from the inside of our home in the winter, that's being drawn out of the house and hitting a metal outlet box, or hitting nails in the attic from the roofing and actually dripping rain into the attic, which nobody's seeing because nobody's going up there to notice. It could be water condensing even on wood sheathing in places where when it's really cold outside, because it's not, wood sheathing is very thin, so it can get very cold, but there's also probably nails. And so that's where you can have bulk water that is happening, which is not actually technically a leak, though it is an air leak. And so it's a complicated topic when people are saying breathable. Well, I know I've had conversations with contractors who have all these holes in the walls, and they say, well, it's supposed to be breathable. No. It's not supposed to be drafty. It's actually supposed to be air sealed. The term breathability is related to permeability. So this is very much related to walls, but it is also related to roofs, as I mentioned, and then how all these materials are coming together, because oftentimes that leakage is going to be between the wall and the roof, between the wall and the window. That's going to be a high location of something that gets overlooked. There's a lot of complexity into how that framing works and how we might insulate that. Insulation is another question I get a lot of questions on, and honestly, some of the inexpensive insulation that we've been using for decades and decades is fine if it's done well. But like everything, you can do something well or you can do it poorly, and so things like fiberglass insulation or any insulation is getting its value, its insulation value from the entrapped air. It needs to be fluffy. So as soon as you start squishing insulation into tiny cavities, you're pushing all the air out of it. It's kind of worthless at that point. So if you're building a new home and you can see that there's, they're doing a great job on the insulation, but then you see some areas that are tricky because there's a lot of pieces or whatever, and so they're pushing insulation in that should be fluffy, and it's not fluffy anymore, then it's actually going to be a place that could be air leakage. air leakage prone because it's not going to be as insulated as we would like. Then we have things of metal. If you have any metal, lots of people are saying, oh, I want to do metal walls because I want to avoid mold, and mold grows on wood. Well, actually mold will grow on any material, including metal, if it's wet and has dirt on it, but metal is subject to corrosion. So I have pictures of a situation which was actually in Hawaii where the metal studs were actually corroded all the way through. They were rusted all the way through. And this was in I think it was a bank or something like that, where obviously they opened up the wall because there was drywall damage. And what was interesting was on the inside. So the inside of this building in a place like Hawaii is air conditioned. So those metal studs were being exposed to air conditioning. The outside is very hot and humid, and there were gaps in the wall. So air from the outside was able to come into the building, and then it's hitting this metal, the metal studs that are cold from the air conditioning side, and it was condensating on the metal. The warm, moist air was condensating, creating bulk water, dripping down the metal studs, and actually rusting them out. In some places, there was almost nothing left. And there was some wood framing around the window. The wood was in perfect condition, not affected at all. So in terms of maybe conventional wisdom, that's not so. In that case, the wood was very durable and the metal was not. So the wood can take in additional moisture and release it when it has the ability to dry to some degree without causing any problem at all. Wood generally has an R value, so where metal does not. We cook with metal pans, but sometimes our handles for the metal pan are wood, and we can grab that handle without a hot mitt. It's because it's not conducting temperature. Are we going to grab the pot without protection in our hands? No way. We'll burn our hands. But the wood, and this is why we don't cook with wood pots and pans, because they don't conduct any temperature, because there are cells of air in the wood itself. Usually the wood has dried and it's dead, and so those cells dry out, and they're air, and they have an R value. And the bigger the piece of wood, the more R value it is, which is why I'm saying that you can have condensation on very thin sheathing, because it is say it's a 1/2 inch piece of sheathing, and it's 20 degrees outside, then that sheathing is going to get very cold. If it's a beam that's 6 inches deep, or even a 2x4, it's not likely to be a situation that will cause condensation, because even a 2x4 is got enough insulating capacity that it won't be cold enough for condensation. So these are all concepts that are actually included, and we have some bonuses with the Build a Safe Home Masterclass. There is a webinar that's Moisture Matters, where I go through all of this. And there's also access to some other videos where I really am diving into how windows are getting detailed. And so we have a lot of other bonuses that go with this. Goldie's asking, is there a better device than a regular moisture meter, like a thermal infrared type moisture detector, which some remediation people use? It has a screen. Yeah, so that when I was talking about that blower door test, what I would recommend, and this is the right time of year to do this. I'm doing this video right now, it's December. In most everywhere, it's colder now than it is any other time of the year. And maybe, I guess if you're in Australia, maybe not. But in the Northern Hemisphere, it's colder everywhere here. Even in the morning in warm climates, or in the evening in warm climates, it's cool. And so with thermal imaging, you're going to be measuring temperature differentials. And it doesn't measure moisture, just know that. Moisture isn't just inherently a different temperature than the air or the materials. No, it's measuring temperature differentials. So what I recommend people do in evaluating their homes, either under construction or before drywall. So I recommend the blower door test before the drywall phase, because our buildings should be air sealed without the drywall. Now you're going to have contractors challenge me on that, and they're going to say, oh, no, the drywall is part of our air sealing. Well, I would argue that is not what it should be, that we should be air sealing our building before the drywall goes up. because two reasons. One, we don't want to end up with condensation that could, or moisture that could be affecting our drywall. And number two, once the drywall is up, it's a lot harder to fix air leakages. So we want to be air sealing before the drywall goes up, and then we can fix stuff because the walls are all open. We can caulk, we might need to use some foam sealant that comes in a can in some little areas that their air is leaking. So the other interesting concept to know about air leakage, especially related to walls, and this is also true for roofs, is that in the olden days when buildings were very drafty, let's just say, before the energy movement to protect our energy in our buildings were drafty. So they maybe had 10,000 holes where air was moving through our buildings. And we probably did not have as many mold issues as we have today because there were 10,000 places that the moisture could accumulate in small amounts, but usually very small amounts. And there were 10,000 places to dry, for our buildings to dry. Once we've tightened up our buildings, and now maybe there's 10 places that our buildings are leaking significantly, know that the amount of air that was moving through those 10,000 places that were drafting our building are now moving through 10 or 5. And so the volume of air is the same as was going through the very perforated, drafty building. But now we have a lot of air moving through very small, very limited number of openings, but they're carrying the same amount of moisture. So we're concentrating our air movement through the enclosure walls or even roofs. And so what was, a little bit of water in 1,000 places now is kind of a lot of water in 5 different places. And so that concentrated moisture can cause a lot more damage to our buildings. So take a look at all the lesson topics in the bonus courses that are included in the How to Build a Safe Home course. There's a sign up in the comments, or there's a link in the comments to where you can go to look for that. And I've said this before, I'm very proud of this course. It's everything you need to know to get started. It's everything you need to be an informed consumer when you need to know how to take care of your home and how to build a safe home and how to know if your home was built properly. Excuse me. Jeff is asking, what is breathable covering insulation for basement walls in new construction? Yes, the basement walls do breathe to the inside. Jeff was commenting that is he assumes that, and that is correct. I mentioned in the foundations section of this that I do not recommend finishing basement walls in the first couple of years of new construction because yes, the basement walls are drying just from the curing of the concrete. So it takes, our concrete gets poured and it's got to dry. If you are doing walls of concrete above grade, if they're poured concrete, it'll be the same. If they're block, they're just going to be a lot more porous to moisture, including rain. So in terms of number one, I wouldn't finish a basement in the first couple of years. Number two, if the basement walls are getting a burden of water from the outside, and this is very, very common, then it doesn't matter what insulation we put up on the walls, it's going to trap moisture in some way. The finish will trap moisture. So we have to stop the inward vapor drive as much as possible. We have to stop the moisture from getting through our walls. In new construction, I recommend waterproofing or damp proofing sometimes is enough, and insulating on the outside. So in new construction, insulate your foundation, get some of that insulation on the outside. What that does is help to reduce the potential for condensation on the concrete. So like steel is transmitting a lot of temperature, concrete block also transmits the temperature of the air and has a lot of condensation potential. People often think, oh, there's no mold growing on concrete. What would be the food source for that? Well, you can just Google that or put in a search engine, mold growing on concrete, and it's all over the place. I've posted a lot of pictures of moldy concrete. Obviously, people have seen it in their basements, mold growing on concrete block as well. Those little tiny pores have air in them in concrete and the more porous concrete block, and they can get dirt in them, and water moves through them in a lot of different ways, and then dirt and dust can be the food source that causes the mold to grow on any material. So in terms of insulation, I think some of the best solutions for basements, once you know your basement is truly dry and that the drainage is in perfect condition, would be or actually a permeable foam board is what I would do. So you could, there's all different kinds of foam. There's EPS and XPS and polystyrene. And so there are some foams, which again, you're going to want to know the permeability rating. You do want it to not be a piece of plastic. We should never, never, never be putting up a plastic sheet over the inside face of any concrete or concrete block. Now, there are people that are putting up in new construction, it's a very inexpensive way to insulate a basement wall, is to use this giant bat roll that they basically don't have to frame anything. So they're not actually putting up any studs. And they just kind of roll this thing over the foundation walls and get to call it energy efficient. They get to sign off on their energy efficiency rating that's required by code. And what they've done is we refer to that product, which usually has a sheet of plastic as a part of it. It's usually white, but it's impermeable. And we affectionately in the industry call that a diaper. So, because that's what it's doing, is trapping the moisture that we can't see that we haven't fixed in the outside drainage, or it's trapping moisture just from the drying of the concrete, or something has changed outside in the drainage. So I've seen places where there's concrete walks that have settled, concrete driveways that have settled. If your driveway is cracked next to your foundation, it didn't get poured that way. There's a good chance that it has settled. It's what caused it to crack. And now water is continually being dumped. That's collecting on the more or less collecting surface of concrete. Even though it is porous and will take in some water, it does also shed water. And so it may be dumping water right up against your foundation. So I hope that's helpful. This stuff is really complicated. That's all I can say. Goldie's asking, I'm not clear. Is it good to get this more sophisticated? So infrared is not moisture detection. I just want to be clear on that. Infrared cameras are not detecting moisture. There is no detector that is X-ray vision to detect moisture that I've ever seen. I've never heard of one. If you know of one, send it to me and I'll take a look at it. The way we can test deeper in the wall is to use extended pins on a moisture meter. Concrete gets tested by drilling a hole, and there's a special tool for that. Know that concrete moisture is always going to be very high, just because it's made out of moisture. It should not be 100%, however. And so the challenge with concrete is just that we're going to trap the moisture behind something, but we also have to stop the moisture from getting there in the first place. This is not an exact, there isn't an exact solution. One, we're finishing basements more than we ever did. And when we did do it in the past, they were getting moldy too. I think I grew up I had a basement bedroom with wallpaper. That is a nightmare. Do not put wallpaper on the inside surface of any exterior walls, especially a brick exterior wall. And to make that even worse would be a brick exterior wall facing the sun, either west or south sun. The reason for that is because concrete and brick are very porous, and there is a vapor drive of those materials when they get warmed by the sun, especially, that drives that moisture to the inside. If your wall is full of wallpaper, most wallpaper is acting as a vapor barrier. And usually ends up with mold behind it. The food source for mold behind it's going to be the glues in the wallpaper. So this is something that, one, if you're building new, don't put any wallpaper on an exterior wall, ever. This is something that was done in a lot of hotels. And I want to say maybe the 80s they noticed it. And then they started realizing there was all this mold behind all the vinyl wall coverings, even in office buildings too. You can find photos online of this stuff, of what it looks like. I know, though, that I've seen buildings that are older buildings where it doesn't look like there's any wallpaper. They've painted the walls, but they painted the wallpaper. So be very, very careful with those situations, because painted wallpaper needs to have the utmost. It's the same as wallpaper, And it needs the most precautions on removing that because it's very, very likely that there could be mold behind that surface. And you can say you're going to disrupt it by taking it off. Yes, you are. So take precautions. You're going to have to do some encapsulation. But it does need to be removed because even though you're going to disrupt it by removing it, you're still getting through air currents from wind currents blowing against the wall. There's still gaps that whatever's behind that surface can be making things worse in the building in terms of air quality, can be making people sick, can be compromising their health. So Jeff is saying I'm helping him save him from the diaper. I'm glad I could help you do that. Jeff, is one of my pet peeves. It's one of the first things I look at in new construction when I'm looking at basements. Most of my clients that I consult with, that's the first thing we're going to remove. Sometimes it has to be put there because that's what the builder is going to do and that's how they need to get the occupancy permit. And fine, then you just do it. Then you just take it off. But I can tell you I had a client here in the Midwest that they knew that house was less than 2 years old, never had been lived in. They were very sensitive, so they knew that. I looked at the home, I reviewed it, and we were going to take all that out. They actually had a remediator take it out. The remediator then, in the process, called me and said, well, there's this drywall on the stairs, by the stair that they actually drywalled all the way to the basement. Should we remove that as well? And I said, yes. And yes, it had mold on the backside. Less than 2 years old. So be very, very careful with your walls and trapping moisture in your walls. Let's see, I'm looking to see if there's any other comments. So there is one final module that is in the Build a Safe Home course that we're not really talking about today because we're doing the 5 basic building modules, but there is another one. It's a bonus module on contracts. And it's actually maybe one of the most important modules in that course because you are only going to get from your builder what you ask for to get and what is in writing to get. And so things like making sure that all construction debris is removed from your home. I mean, we don't want to buy something that's full of dirt and debris, which includes our ducts, our HVAC system. People shouldn't be using our HVAC system that we're going to live in and blow air through for our families and breathe during the construction process. And that doesn't mean we're just going to go cover it up. What I see them doing on job sites is there's so much dust and especially sanding of drywall that they end up removing the filter out of the furnace because it's getting clogged too much. So, and they're using the furnace to dry the air, and that should not be done. So I would be making that perfectly clear. I'd have it in writing. Actually just saying that there's going to be no debris left in the building when you're done will cover you because if there is silica dust in your ducts when it's done or in your furnace, then that would be construction debris. But also that they're going to take caution about protecting the materials on the job site and about keeping the building as dry as possible and about scheduling in a way that they don't leave everything open for weeks on end because something is being delayed. So there's ways to protect our materials that way in planning. So, but it needs to be written. It needs to be in your contract. The other thing is that the drawing is an image of what you're going to be building. There's another document that needs to go with the drawings, and it's called the specification. And what the specification is in words describing what materials and the quality of the materials that you're going to be getting. Most people don't realize that there's actually many grades of wood. So the wood studs themselves, they could be utility grade or they could be structural 1. Very different requirements and price on what you're going to get in that kind of wood. We should be specifying the moisture content of the wood that we're going to receive. That's new construction. And I've talked about this in walls, where usually I talked about it in roofs. It would be the same for walls. We want moisture content 15, MC 15. They can get it. It's unfortunately something I think right now where most of the time they'll have to order it. But that means your wood is coming at a moisture content of 15. And I have another video about all about that. I can't explain all of that now, but just know there's so when we get wood, typically it's going to be moisture content 19. So know that moisture content of 20 is where mold will grow on wood. So do we want to have moisture content 19 when mold can grow at 20? And know that the building is going to continue to dry. The wood materials are going to continue to dry. So these are all the things that we're talking about here, and the questions that you guys are bringing up are the kind of thing we talk about in our live calls with the Build a Safe Home. So the next one is December 29th for our students in that course. It's a lifetime membership as long as I'm alive and we're doing this. You have access to this. It is a course that I do recommend you try to focus on for 6 weeks, but if you have to do something else for 2 weeks, that's fine. You can come and go as much as you want. I have some super students that have banged it out, and that you can go back and look again. So say you're getting into the project and you think, I got to go back and look at that walls section. But get the course before you do the contracts with your builder so that you can see that section, and that you can make sure that your contract is as clear as possible, as neutral as possible. So a lot of builder contracts are written to protect the builder. A fair contract will protect the builder and protect the homeowner, because the builder could not go out of business too, or he could stop working. So you want to protect both sides. That would be fair. And anybody who's not willing to be fair, play fair, I wouldn't want to work with them. So Karen's asking if ventilation systems play a role in safe homes, and what systems do I recommend? And I think Karen, you sent me an email that I did see quickly this morning about ERVs and HRVs. And those are energy recovery ventilators or heat recovery ventilators. Which one you would use depends on your climate and your needs. They're new-ish, let's just say that. I built my house 15 years ago and I did not put one in. They were very new then. Nobody knew what they were doing, and I was exhausted with teaching people everything that I needed to do in my home. I don't regret not having one. They're not a solution to keep your building mold safe necessarily. If your building is very tight, and this I will say is going to be only really well-built new construction. There's a lot of new construction that's not well-built. There are situations where you basically the door closes and another door opens because the building is so tight. It's very unusual. In existing buildings that you're renovating or whatever, I actually don't recommend them, because the building is more drafty than you realize. If nothing else, I would do a blower door test and investigate where the building has its leakage flaws and try to control that. The other thing I do recommend on ventilation is, one, to have an alternative be that you can open windows. On any kind of mechanical bringing in outdoor air systems, we want to be able to control as much as possible if we're bringing in hot and humid air or super cold air in the winter, because there are times of the year, especially situations if you're in a part of the country where there's forest fire smoke, for instance. You do not want to bring that air in, and it could be for months that you need to turn it off, because you're actually trying to keep your air clean on the inside of your home. You don't want to bring in the outdoor air. It could be a situation where it's raining for days, even in one day. It's 100% relative humidity outside. We do not want to bring that air into our homes. And that's actually what I see as a big problem in the Southeast, especially, where people are putting in ERVs. And as a solution for mold, thinking all this ventilation is going to help, and it actually is hurting. They have more mold. So our heating and air conditioning systems cannot handle having an open window all the time. That's basically what it's equating to. ERVs and HRVs are not dehumidifiers. If you can find a system that includes a dehumidifier, that would be something that I would consider, but you do want to be able to control it. So it's, again, a very complicated topic. In terms of the Build a Safe Home course, we talk about, in the building design section, we do talk a lot about ventilation and how to plan for that, and because that is critical. And it does need to be done in the design process from the beginning. So I run across a lot of people who their drawings are done. Maybe they've even started construction, but nobody has ever discussed how the heating and ventilation and air conditioning is going to work, where those ducts are going to go. That should be part of the design process. We're going to design our systems the same way we're going to design our wall or our roof or our floor plan or our foundation. Everything has to be designed together for a comprehensive system that's going to work well. So, yeah, so I think we've probably talked long enough. I don't know if there's any other questions. Crystal, if my assistant Crystal is online here and if she can see if there's any other questions. But I do come on live. Check out the Build a Safe Home course. Join us there. You have lifetime access to it. If what you're getting in the introductory course is helpful, know that the master course is 6 times more, if not more than that, because there's actually, I think we're up to about 14 hours or more, probably more than 14 hours now, of Q&A sessions that you can knock yourself out, and I use pictures and people ask great questions that are little nuances to all these topics like we're talking about here today. So look in your email for the builder checklist. You'll get that today, and a promo related to the Build a Safe Home course, and check it out. I would love to see you. I'd love to see those of you who've been here and who are building in this course. There's Crystal's saying there's actually over 30 video lessons across the 6 units. So it's done. It's not overwhelming, but it is a lot of content, and but it's chunked out. So you just kind of pace yourself through it. So so that's what I suggest. I would love to see you there, and I know that it's helpful. I got great reviews from people. If you want me to be involved in your new build, also make sure your architect's okay with that. It will work. That will work best. They should be okay with that. I'm very collaborative, but get that course, and that course can be a huge cost savings to basically listen to me talk for all those hours. And then we can go into specifics related to your specific situation. So, with lifetime access, does one have lifetime access to my live Q&A sessions? Yes. This is for the people. There are some people that took the beta version of, I think, the Build a Safe Home course way at the beginning. Some of those people were allowed to upgrade. They had to pay for an upgrade. So it's with the full course. So the course has improved and become more and more robust as we've gone through. So if you're one of those people that took it years ago when it was supposed to be a 5-day course, and then I realized I put way too much content in it, then there may be some upgrades that would have to happen for you to have access to that. But yes, anyone who is signing up for the full course gets lifetime access to the Q&As forever and ever, as long as I'm doing this. Like I said, it's basically 4 to 6 weeks usually. And yeah, bring on the questions, and I'm always happy to hear what you have to say. Let's build better buildings. That's all I can really say. Thank you for being here. Thank you for being with us for this week. And love to hear your feedback on the introductory course. Don't forget to watch it because it's going to end. It's going to end soon. So thanks again, and I will see you on the next video. Bye.